Writing automation scripts. So when I came across this objective for 464, I thought, this is cool. This isn't something you see very often, because normally when Microsoft lists an objective, they just have a bunch of things that we need to know. This objective is more a bunch of things that we need to know how to do. So they're actually challenging us to come up with solutions to everyday problems. Or in our case, come up with solutions to those weekly mundane tasks that every DBA has on their checklist. And then automate it, which is like the ultimate goal of every administrator, as long as we don't automate ourselves out of a job. But that would never happen because we have big checklists and endless things to do. Am I right? All right, so anyway, this nugget, we're going to have a lot of fun. We'll start with just a quick overview to go over the tools and technologies in and around SQL Server that we're going to use for building and then automating. And I'm talking about SQL scripts. Obviously, it's in the title. So SQL scripts are a big one. If we can make a script out of it or make a stored procedure out of it, it makes it real easy to automate and turn it into a job in SQL Agent. Also, PowerShell. Even though PowerShell isn't you won't see it as a requirement anywhere in any of the SQL Server 2012 exams. It will be in the future. It's one of those skills that if you don't have it now, you're going to have it eventually, because Microsoft is heavily integrating it into everything on the server side, and it's going to be our go-to tool in the future for administering multiple products or integrating multiple products together, creating processes across multiple server-side products. So it's good to get familiar with it sooner rather than later. And also SSIS, what I like to call the Swiss Army knife of SQL Server, because we can use it for everything. It was built really for ETL type stuff, but you can use it to do literally anything that you can put your mind to. We'll also go over just a short checklist of what some of those common mundane tasks that can be automated are in the world of SQL Server. And if you're a DBA, you probably have a checklist that you go through daily, weekly, monthly. Maybe it's a mental checklist, maybe it's a physical one, but look at your checklist. Is there anything on there that you can automate? And if there is, try it out. We've got a lot of tools to help us here, and hopefully this nugget will get you going with what some of those tools are and how we can use them. So once we get through our whiteboard, we're going to take a lot of demos. These are all demonstrations. We're going to do each one a little bit differently using different tools and techs. We'll start here with automating backup testing. And for this one, we're going to use PowerShell to do that. I created a cool little PowerShell script that uses both SMO, SQL management objects, along with a couple of nice commandlets to do backup, restore to a test database, test the restore, and that's really all we should need to do. The reason you need to test your backups is because you can back up all day long and run verify and checksum, but that doesn't mean that when you restore it, people are going to be able to access it. The only way to truly do that is to restore it and then run a check DB on it, a DBCC check DB. That will actually ensure that all of our pages are intact and our the data integrity is where it should be. Because if you don't test your backups, then you're asking for a firefight. When that day comes that some page got corrupted and now errors are popping up all over the front end, you're firefighting a problem. Where if you automate backup testing, by going through that process, backup, restore, check DB, and all of that succeeds, then you're golden. And we can automate this whole thing by setting up a SQL agent job. And if our test restores and our check DBs fail, we can be proactive about it and save ourselves some future stress. So we'll check out the PowerShell script for the process, and then we'll automate it using SQL agent. From there, we will do a SQL script to automate backups. And here we're going to refer to Ola Hellengren's backup script because it's awesome, it's free, and it's loaded with all the options you could ever want in your backups. And it's really easy to use as well. So we'll do that, and we'll see how to automate that in SQL Agent. Then we will use SSIS for automated data archival. So here we'll whip up just a quick SSIS package that will take data we have the perfect table for this, by the way. Our Learner Nugget activity table is a table that we're saying could have thousands of rows every day entered, maybe even more than that. And so this is the kind of table that we want to keep thin and small in the front end and archive all that data to a data warehouse for analysis somewhere else. So we'll use SSIS to do that. Then we will deploy the package and we'll automate that SSIS job in SSIS. Then at the end, we're going to use a stored procedure here to automate a disk space check. We'll do a stored procedure. We'll set up SQL database mail, and we will send a notification to ourselves whenever the disk falls below a certain threshold. That's also going to be a fun one, an incredibly useful one to know. So we've got a lot of good real-world stuff in this one, and I'm going to challenge you here. Here's a good one. Once you watch this nugget, pick one of these. Let's say automate backups. Pick one of these and do it using each technique. And this is just a great way to learn. By doing one thing using multiple techniques, you get some good perspective on how to do stuff. It's like exercising your brain. We are here to pump you up. That was my terrible Hans Franz and Schwarzenegger impression all rolled into one. All right, let's get to it. So as far as automation goes, we've got lots of tools to help us build our tasks and our processes. SQL scripts, obviously, if we need to do anything in SQL, and even to an extent outside of SQL, we can use SQL scripts there. They're great for everything SQL specific, and as a bonus, they're easy to automate. Integration services, love integration services. It's just great. It's actually fun to work with because everything's graphical. You drag and drop, you set some properties, you deploy, you automate, and you're done. And again, it was really built for ETL stuff, but you can easily do maintenance tasks, and as I mentioned, really anything you put your mind to. And then there's good old PowerShell, our administrative tool of the future that we can use to create processes or tasks that span multiple products on the server side or work with a single product. The beauty of PowerShell, if you've ever written a VB script, I remember back in the DTS days, I loved when DTS came out and they had the little module task that you could drag on your DTS designer and then write VB scripts. You could do OLA automation, even on the SQL side with SPOA create, SPOA destroy. All that stuff goes away. And those were bound to SQL. Now we have this generic tool that's at the operating system level that we can still work with not only SQL, but all these other products, but it's easy to work with. Let me tell you, and I'm going to show you this. I know I'm going a little overboard here, but I want to show you when we get into the Virtual Nugget Lab how in just a few lines of code, we can get a reference to a server, a SQL server, and enumerate all the databases and then do something against all those databases. It takes very little code, and if you're not familiar or comfortable with coding, it's really just a little bit of syntax to learn. It's not bad. But I promise you, if you learn PowerShell, there isn't much you won't be able to do or automate on the server side. Stepping down off the PowerShell soapbox and moving over here to SQL Server Agent. If you're watching this, you probably know all there is to know about SQL Server Agent, but it is what we're going to use to automate all of our SQL processes. So we're going to use it to automate SQL scripts, we can use it to automate our integration services packages, and we can even use it to automate our PowerShell scripts. Cool. So we'll be doing a lot with that. We'll be creating jobs, attaching schedules and notifications, and the whole ball of wax when it comes to SQL Server, because that's going to be our go-to tool for automating things on the instance or server side. So what are some of the common tasks that you're going to see DBAs attempt to automate? Backup and restores, that's probably the big one. Partitions, files, and file groups, anything that has to do with maintaining our database files, absolutely. Same with log file maintenance. Data integrity is always a big one. We want to ensure that our data is of the highest integrity, so data integrity checks. Ola Hellengren has a great data integrity script as well that I'll show you. Transferring data, moving data around, ETL processes to push our transaction data to our data warehouse is always a popular thing and a popular one to automate. And then obviously another big one here, index and statistics maintenance, something that we looked at in a previous nugget. With that, let's head into the Virtual Nugget Lab and do some work. All right, we're in the Virtual Nugget Lab. Let's head into Management Studio and set the stage for what we're going to do. So we've got a new project in here, 09.automation. We're going to start here with backup testing. How can we do backup testing? And remember, the idea here is that whenever we do a backup, if we just do a backup, and sure, we could do a backup with checksum and verify that will verify the integrity of the backup itself, but not internally, not the data. So if we do backups and then the day comes where we need to restore, and we restore a backup that has some corruption in it, we're in big trouble because now we're chasing our tail trying to find a valid backup, right? So that's why it's a good idea to test your backups. And testing your backups means backing up, restoring, and running a database integrity check such as DBCC check DB. That will ensure that our backup is good and there will be no surprises if a catastrophe were to happen and we need to recover from that backup. We know that it and everything about it, data all the way up to the physical backup file, is good to go. So we're going to use a PowerShell script that I threw together to make this happen. And here's what it's going to do. We are going to back up into this backups directory right here. So this is where all the backups will go. So we're going to back up all the user databases. We have 3 of them. And then we're going to restore them as database underscore test. So we'll get 3 more databases, one for each of those with an underscore test appended to it. And when we do this, we have to move the underlying files. So we're going to move them into our restores data and log directory here. And then we're going to run a check DB against all the tests. If everything goes smooth, then we'll know. If we get no errors generated from CheckDB, then we know everything is good. We can also then automate this PowerShell script in SQL agent and then set up notifications so if the job fails, we know that we have a bad backup. And I also have a corrupted database here. I made a corrupted database, and to do this is actually kind of fun. Create a database, create a table, put a bunch of files into it, and then use a hex editor to find page with data on it, and then just change a value, and that'll corrupt the page. So that's what I did. I've got a corrupted database with a corrupted page inside of here. So once we do this successfully, so you can see what it looks like, we will restore this corrupted DB, and then rerun our test process to make sure that it works, and we will get notified that we have an invalid backup. Because a corrupted database is fine, you'll be able to back it up fine, you'll be able to restore it fine, but when somebody runs a query against a table that has a corrupted page, that's when chaos begins. So CheckDB prevents that because it checks at the page level to make sure everything is intact. So the first thing I want to do here is just take you through this PowerShell script. So I've got some help up top here. So if you were to do a help on this, this is the information you get out of it. Just a little synopsis, description, and an example of how to use it. The first thing I'm doing here is just setting up some command line arguments. Because when we call the script, we're going to want to pass in the server name, the backup directory, and the restored directory. So that's all we have here is setting up these as mandatory parameters. And that's then how, when we call the script, we're going to need to pass in the SQL instance, the backup directory where the backups will be stored, and the restored directory where the data files for the test databases will be stored. We set up some error handling here to define what to do when an error happens. It's just going to spit the error out to the screen, write the output here to the screen. And then this is just a little safety check to see if it loads up the SQL PS module that contains all the SQL stuff that we want to work with, the SQL objects that we want to work with. And there's a couple of ways to do this, by the way. If you launch PowerShell inside of SQL Server, which is on virtually every right-click menu in Object Explorer here, you can start PowerShell, which will preload it with the SQL PS module. If you launch it from outside of SQL Server, which is what we're going to do right here, then you will need to explicitly load the SQL PS modules. So that's all this is. This just checks to see if it's already loaded. If it is, great. If not, then it's going to import the module and load it up. So next is the good stuff here. We're going to connect to a SQL instance. Look how easy this is. We're going to create, using SMO, SQL Management Objects, a server object. And we're going to pass in the name of the server that comes in from the command line. That's it. That's going to get us a reference to the server object. And now we can get a list of all the databases by doing server.databases. Cool, huh? 2 lines of code to get a reference to a server and get all the databases stored inside of a list, a collection, or an array here. Then we're going to back up all the user databases. This is all the code to back up a database. Pretty easy. So first we're creating just a collection here to store it. Then we're going to loop through all the databases that this server .database is returned. Every time we hit a database, it's just going to check to make sure it's not a system object. So we're not doing system databases here, just user databases. Then we're just going to create some variables to store information to create the backup file. So we're going to get the database name, we're going to get the date, time in this format, and then we're going to create our backup file path, which is going to be the backup directory that we pass in from the command line with the db name underscore date dot back. There it is. There's our backup file name. Then we're going to create the actual backup itself, and then this is it. This is the awesome commandlet for doing backups. Backup-SQL database, we pass in the server instance, the database name, we get that here from the loop, the backup file that we just created. Initialize means overwrite if it already exists. We're going to turn compression on, and whenever you're doing testing, you want to do copy only so we don't mess up our real backup chain. Right? So here we're utilizing copy only, and that's a great way to use copy only. So that's it. That's going to create a backup file in this directory for each user database. How easy was that? Not a lot of code to do that, right? Now the next thing we have to do gets a little bit tricky, just because what we need to do is move the log file, or move the data and log file associated with the database. So the first thing we're doing is we're just going to set up the data and log file paths. Then we're going to create them in Windows here if they don't exist, which, here, I'll blow them away so they don't exist. Ready? We'll blow them away. So those will get created. Now, if they do exist, this code will just ignore them, hence the if statement there. And then here comes the big restore loop. So this loop's going to happen for each backup that we created. So for each backup, it's going to get the backup file itself. This is going to be the path to the backup file. We're going to make the new database name be the existing database name with underscore test appended to it. We'll create a collection for the relocate file objects. Then we're going to create a backup device. This is just like when you're inside of the restore dialog. You need to choose, what are you going to restore from? Well, we're going to restore from an actual physical backup file. That's why we're creating a backup device based on a file that points to the backup file that we're referencing inside of the loop. Then we're going to create a restore object. Our database name is going to be our new database name with an underscore test appended to it. We're going to add that backup device to it and then replace the database if it already exists. Then we just have a couple of lines here to specify the physical file name is going to be under the current name of the database, test underscore data.mdf and ldf. So we just set up our physical file names there. Then we need to read the file list so we can then get the logical file names out of them. And we'll just specify D and L, D for data, L for log. We add those into the collection because we're going to call this restore SQL database commandlet, a lot like our backup SQL database, where we pass in the server, the database name, our actual backup file, our relocate file objects, and then with the replace database flag equals true, which we already set up there, so that's probably a little bit redundant, but that's it. That will back up and then restore to underscore test. Now, because we added new databases here, we just call a refresh method on that server.databases collection, so we'll get an updated list of databases that contain all the test databases. And here it is, the loop for checking the databases. We're just going to loop through all the databases, make sure that the name ends with test, so we're not going to do a check DB on existing production databases or any system databases, and then we'll just write out to the host here with a background of yellow and a forecolor of black, checking database DB name. It'll run the check DB. This is DBCC check DB, by the way, the check tables method on the database object, and that'll check it. So if everything is smooth, everything will just end. We won't get any status messages or anything. But if there's corruption in the data page, then we will get an error thrown to the screen with all the message, all the information we could ever want. So let's run this without any corrupted database to see what it looks like and to see what successful backup, restore, and check DB would look like. So with PowerShell up here, let's just change our directory to our Nugget Lab files. All right, we're here. Now we can just simply do this. Let's run it. The name of this script is backups. There we go. All right, so let's hit enter. This should do its thing and hopefully work. Hey, there it is. Check it out. So it's working right now. It's backing up all of our user databases. There it's outputting that it created our data in log directory. And now it's going to start restoring them as underscore test. There's AdventureWorks. There's DW AdventureWorks. And the last one should be our Nugget Demo DB, which is bigger than the rest of them, so it might take a little longer. And then it's going to output that it's checking each one with a DBCC check DB. Hey, there's the results. Look at that. So it checked the databases, and everything panned out. We didn't get any errors thrown, so we know we're good. So we could easily automate this now by making a SQL job out of it. And then we could just put, if something errors in that SQL job, send us a notification with the information. Now let's bring that corrupt database on here. So I'm just going to restore this corrupt database. Let's browse to device here. Add this in as our new database here, corrupted DB. Okay, looks good. So let's hit OK there. That'll create it. And now if we run this again, we should get an error this time because this is a corrupted database. And by the way, you can see it's corrupted if we create a new query. And let me just do a select star from some data, or some table, sorry. Some table. So it's going to work all the way up to the point where it hits that page. And then it's going to say we've got a consistency error, we've got an invalid page in here, so on and so forth. All right, so that's bad news. We've got a corrupted page, and that's going to cause all kinds of problems in the front end if someone were to read that record. So I deleted all the test databases. That's about the only thing missing from the script. That'll be a good challenge for you, is expand this PowerShell script to remove the test databases when they're done. Now, another way to do this, probably a better way to do this, would have a test server. So these databases, you wouldn't have to delete them. You always just leave them there. And then when you test your restore, you leave production alone. You just back up, restore to your test instance, and then leave them there, and then just have overwrites on, so it always overwrites them every time you do it. So I went and deleted the existing ones. Now let's run this again. I'll just go back to PowerShell here, hit up, rerun the script. It's going to go through the whole process again here. Only this time, when it's checking our corrupted database, we should have an error. All right, so there you go. It's restoring AdventureWorks, restoring corrupted DB, and it works good. So you can restore fine, right? It's when somebody tries to access it, we get a problem. So this is what check DB is for, and when it gets down there to running CheckDB against all these databases, that's when we'll get the error, not during the restore. All right, here it goes. Checking AdventureWorks. Good, that should pan out. Checking AdventureWorks DW. That should pan out. Checking corrupted DB test. Oh! So the next step then, and the last step for this task, is to automate it. So we can head back into Management Studio, head down to SQL Server Agent, right-click on Jobs. We'll make a new job here. We'll call this our Backup Restore Tester. And if we head into Steps, we'll create a new step. We'll call this step, how about Do PS. Drop down our type here and choose PowerShell, and then we can just pass in our command line, which I have on the clipboard here. Just keep in mind if you have a space in the path of your script to wrap it with an ampersand inside of parentheses and quote it, and that should do the trick. So now we can hit OK. We can go down here to schedules, and we can schedule this to run whenever we wanted to run our tests here. On the notification side, let's go email. I've got database mail set up to my Nugget Lab Gmail account, so we'll choose that profile there. And we'll say whenever this job fails, send an email to me. So I'll know that every day when our backup test runs, if we have any sort of problems at all, then we will get an email and we'll know when we need to manually intervene. So that's set up the job. Now, the only hole in this process right here for this demonstration purpose process is that SQL Agent doesn't know if this error is out or not. So we actually would never receive that email. A better way to do this, in fact, I'll leave this as a good challenge for you if you want to try this, is to integrate the email and error checking into the PowerShell. This should all be contained in the PowerShell, and that way we just use SQL Agent as the driver, just as the scheduler, and that's pretty much it. Fire off the job on this schedule. But this way, too, you'll notice one little hole in here is that when it found the corrupt database, it didn't continue on. It didn't do the Nugget Demo DB test. It didn't run CheckDB against that. So what we would do here is turn error handling so it continues on an error. We would check the results of this, and if there's an error, stuff that into a message, email it. And do that for every database that it would have a problem with. That would be correct design, and there's a good challenge for you. Moving on here, let's see how we can automate a backup strategy. And we're going to use a real-world one here. We're going to use Ola Hallengren's backup script because, again, it's awesome, it's free, and it's easy to work with. So I've got his script here. How we're going to use this script is we're going to set up a backup strategy that contains 4 backups. We're going to do a weekly full, a daily differential, and an hourly log, along with a weekly system database backup. So first, let me take you over to Ola's site once again here. If we go over there, we looked at index and statistic maintenance. We saw how to work with that one. Check out integrity check when you get a chance. That's an easy one. But here is our backup one. So the first thing you want to do is just download it. You can do that by going over to downloads. You can download database backup and make sure you also have command execute there and optionally command log if you want to log any of this stuff. But if we go back to SQL backup, it's really easy to work with. The main parameters here are going to be the databases that you want backed up. System, user, all, or specific databases. The directory or directories you want them backed up to. The backup type, full differential log. If you want to verify the backup, as we just saw, that's good because you can verify if the backup can be restored, but it doesn't actually verify the data. That's why we do a CheckDB. Cleanup time is nice. You can specify how long you want to keep up your old backup files. So the beauty of this is it has checks in it that will make sure it does not back up your current does not delete your current backup chain, so it won't mess that up at all. Always make sure that the backups that are active are intact. This is only for deleting old backup files. You can turn compression on, copy only, so it's got all the options we would want it to have, right? And they're easy to use. Also, change backup type is pretty nice. You can't do a log backup unless it has a base of a full backup. So if you do a log backup and you have change backup type to yes, and it can't do a log backup, it'll fall back and do a full backup. Kind of cool there. It also works with other backup software, checksums, and there's some other options in here as well. So I've got that installed in our master database, and I also have it down here for reference. We could easily reinstall it if we want to. But all we're going to do is just call this stored procedure multiple times through multiple jobs with different parameters and different schedules. So we're going to do the first one by hand, our system job here, and then I've got a script that'll create the other ones for us. So let's just right-click on jobs, hit new job. We'll call this one backup system DBs. And then on the step side, we'll create a new step here. We'll call this one do backup. And I will paste in the command line, which, by the way, I have referenced down here at the bottom, how to automate it using the right command line. Ola Hallengren also has them on the site, so you can see a reference there. just a couple of things. We're doing this through SQL commands, so we can pass in the server, the database, and then the query associated with it, so we can pass in all the switches as parameters to the stored procedure, basically executing a stored procedure there through SQL agent. All right, so we do that. We hit OK. We can set up a schedule here. We can say we want this to run weekly on Sundays, which is the default here at 12 a.m. That looks good. We could also then set up notifications, so if the job were ever fail, we would get notified. If not, as long as it's succeeding, everything is good. So we'll hit OK, and there we go. We have our backup system DB's job ready to go. Now let me open up our script for the other jobs. This is just going to create all 3 jobs that span our full differential and log backups. All right, so we'll hit execute here. That'll switch to the MSDB database, create them. Now if we refresh our jobs, we should have, and we're just doing this for Nugget Demo DB, but there it is. So here's our full. If we look at our full, we can see that it runs, we have do backup. The schedule is going to run weekly. This our full, we're saying do the same thing, run it weekly at midnight. Looks good. Our differential one then is pretty much the exact same thing, just with different parameters in our do backup step. And on our schedule side, we're doing it every day at midnight. And then our log backup, we are doing every hour. So that's it. There's how you can automate a backup strategy. Pretty straightforward. And again, there's lots of ways to do that, but I believe for the real world, Ola's probably got the best way here, just because the script contains everything you could ever want it, and it's easy to work with, and it's solid and tested, and lots of people use it in production. So you can have some faith and trust knowing that it's a pretty solid script. Moving on, the next thing I want to do is show you how to automate data archival using SSIS. So I think the idea for this objective is they just want to make sure that you can automate an SSIS job, create a SQL agent job that is based on an SSIS package. So I've got a package here called archive learner activity that has an execute SQL task that creates our archive table. Now again, in the real world, you're probably going to have a data warehouse or a different database that hosts your archive information. But here we're just going to create the same learner nugget activity table with archive appended to it. Everything else is the exact same. So let's just check to see. If the object already exists, it won't recreate it. So you could run this multiple times. Then we have a data flow task where the source is going to be a query. And this is a great way to do data archival by using the output clause. So we're doing a delete from learner nugget activity where the year is less than the current year. So it's going to basically remove everything that isn't in this year and move it into the archive table. So and by doing a delete, it's going to first remove it from that table. Then all those deleted rows are going to get thrown down in our data flow, which are then going to get entered into our archive table. As we can see it, we have that table doesn't exist. That's why we're getting this error. But if we did this, here, let me create this real quick. Execute the task, create the table. Just thinking about it. All right, there we go. Create the table. Now if we go back into the data flow, this will work because that table exists. All right, so we're all mapped up. And by the way, this is all transacted, so if the delete were to fail, don't worry, the records wouldn't disappear. The whole thing will get rolled back. But if everything succeeds, then all the deleted rows out of our production table would then show up in our archive table. All right, so first, before we run this, we need to deploy this package. And in order to do this, we need to set up an SSIS DB catalog. So if we head into Integration Services Catalogs in Management Studio, we can create the catalog, and we'll just go ahead and type in a password here. Okay, looks good. And now we will be able to deploy that package here into SSIS and SQL Management Studio. So all we need to do is right-click on our project, head into Deploy. That'll walk us through the wizard here where we're just going to specify our server. We're going to specify our path here. I'm going to create a new folder, call this 09.automation. Hit OK. Hit OK. And that's where it's going to deploy it to. All right, so we're good here. Deploy. And now if we head back over here and refresh, there's our folder that we created. Here's our project. And there it is. It's already done and deployed. Perfect. And now before we automate and run that, let's just go make a query here against our Nugget Demo DB. And let's just select everything from Learner Nugget Activity. And it should equate to about 1 million rows, but you can see our action time here. We have a lot of old data in here. So the idea is to get anything that isn't in the current year being 2013, that will get pushed into that archive table. All right, so you can see that we have 999,901 rows. So we need to make a job out of that package. So we'll right-click, choose New Job. This job will be, how about Archive, Data. Our step here will be Execute SSIS Package. Our type then is going to be SQL Server Integration Services Package, where we're just going to specify what server we want to work with and what package we want to work with inside of our server. And this is the one we just deployed right here, archive learner activity. We'll hit OK. We'll hit OK. We can do this on a scheduled basis. Once again, we could set up notifications. But this looks good. We can hit OK. And now if we right-click and run it manually, that's going to start the job and push all that data from our Learner Nugget activity production table to our archive table. And the end result then should be, I think it'll be like 30,000 records or so, or 60,000 records for this year should exist then in our Learner Nugget activity, and the other 930,000 should now be in our archive. So let's check it out. And there it is, 62,000 here. And if we look at our archive table, then we will have the rest of it. There we go. So this will contain the other rows of data that aren't in 2013. So that's a simple one using SSIS for moving data around. Another one would be partitions and partition switching, which we talk about in 70-462. That's a great way to move archives around and then manage it at the file level. All right, the last thing I want to show you here is disk space notification. This is a cool one. There's a lot of ways to do this. You could create a WMI alert, for instance, but I think a good way to do this is with a stored procedure, and then we can just automate that stored procedure. And this one, we will actually get notifications. Now, here's what I did. I went in and I created a virtual drive in here called Rutrow. 466 megabytes out of 4. So I made a 500 meg drive. We're going to create this stored procedure that monitors our drives, and we'll send a notification to our email if a drive falls below 500 megabytes. So that's what I did. Created a Rutrow drive that is just below 500 megabytes. So now it's our job to create a stored procedure to monitor all the physical drives on our system. We could do this one of two ways in SQL Server. We could use the extended stored procedure, master sys XP fixed drives, which is really cool and easy to work with here. Let me just switch our database to master. There it is. Check that out. Cool. It just lists all your drives along with their free space. We could also monitor disk usage at the database level if we wanted to. Check that out. That'll show us all of our databases and how much space they take up. But what we're going to do is this one, because this is what it calls for, automating disk space checking at the system level. So we're going to create a stored procedure called disk space notification. So this is a pretty cool little stored procedure because we just create some variables for holding data that we're going to use in our email. Then we create a table variable here that is going to store the results of executing that extended stored procedure, XP fixed drives. Then we're just going to query that table and store inside of our variables any drive that is less than a gig. I said 500 megs, but I meant a gig. So anything else that's less than a gig, then we're going to create this email, insufficient disk space notification. We'll give them a nice message. Hey there, sorry to bother you on this fine day, but your disk is low. Format it with some nice HTML and output the drive, how much space is left on it, the server that the drive is on that is low, and then we'll thank them and wish them a wonderful day from support. And then here's the magic, send DB mail. And I did set up DB mail here. If we look at it, we'll right click and go to configure, just walk through the wizard here and show you manage an account, view and exchange an existing account, and here it is. So I set this up pointing to Gmail. If you do this, just make sure you point to smtp.gmail.com. Port 587. It requires SSL, set up basic authentication using your Gmail account. You can also do this with anything really, Yahoo, Live, or Hotmail, whatever. You can do it all. So that looks good. Let's create the stored procedure. We'll highlight all of this, hit execute to create it, and now we can make a job out of it. This time we'll make a real job with notifications and all. So we'll call this one check disk space. Steps here, we're going to create a new step. It's going to be transact SQL. We'll call this do sproc, and we're going to execute the name of that sproc, which was disk space notification. I'll just copy it here so we can paste it back in. There it is. Execute disk space notification. We'll hit OK. We can set up a schedule. For this, we would probably want it to run maybe every 10 minutes. Sounds about right. And it'll only send the email if it does have data in there, by the way. So we'll send this, we'll do daily occurs every 10 minutes. So it'll check our disk space every 10 minutes throughout the day, every day, daily. And it should be good. We've got notifications built in to our stored procedure, so we don't have to worry about doing this at the SQL level. That's it. So now we can hit OK, and rather than wait 10 minutes here, I'm just going to right-click on it and choose Start Job, and we should get a notification in my Nugget Lab email, which I do have up here, that will give us the results. Come on, let's go. Where are you, email? There it is. Look at that. That didn't take too long. Here it is. Hey there, sorry to bother you on this fine day, but our disk is low on the E drive, 466 megabytes remaining on SQL Nugget Lab. See, wasn't that a blast? I love automating things. It's so cool once you get something to work, and then make it work automatically. It's a whole new level of awesome. In the CBT Nugget, we learned how to write automation scripts. We started off with an overview where we got familiar with the tools of the trade, the tools that we'll use to create these processes to automate, things like regular old SQL scripts to SSIS all the way to PowerShell. And then we jumped into the virtual Nugget Lab. We learned how to do and create a backup testing plan using PowerShell. That was a fun script. We learned how to automate backups using regular old SQL scripts. In this case, we use Ola Hellengren's awesome real-world and free SQL script. We saw how to automate data archival using SSIS, and then we saw how to automate a disk space check using and building our own stored procedure, and we automated all of them using SQL Agent. I hope this has been informative for you, and I'd like to thank you for viewing.